Hi everyone, welcome back. Today we're solving count partitions with maximum difference at most k. So the problem is basically what the title says. We will be given an array nums and we want to divide them into subarrays. For each subarray, the difference between the maximum and the minimum element can be k at the very most. And we want to return the total number of ways to partition nums following that rule. So if we look at this example, we can do it this way. Obviously, we can split them all into subarrays, or we could split it this way because 3 and 7 does not surpass k of 4. If we split it this way, 1 and 3, 3 minus 1 does not surpass 4, 4 minus 1 does not surpass, and because both of these work, we can combine them together and still make that a way to partition. And finally, 4, 1, and 3, 4 minus 1 is less than 4, so that is also valid. And that's why we return 6, because there are 6 ways. So now that we have seen some example, let's get to how we can solve this problem. So I won't go over this way in detail because 1, it's not the optimal solution, and 2, it's very similar to the optimal solution. So if you don't understand what I say here, then maybe you can look at the example walkthrough and the optimal solution, and you'll probably be able to understand. So basically, first we will initialize a sorted list, dp, with the first element as 1 and the rest being the length of the array, all filled with zeros, and same with prefix. So the first for dp and prefix would be the empty array, and then this will signify index 0 in the array, and this will signify index 1 array, and so on and so on. So dp will show the maximum number of subarrays that can be formed following the constraints of the problem at that index. So for example, in an empty array, at this index we can have an empty array, and at this index we can have 9. And prefix will keep track of all the possible subarrays at that index. So for example, here in the beginning we can have an empty array as always, and over here is 2 because we can have an empty array and we can have a subarray of just 9, and we will use a sorted list as we iterate through the array to keep track of the window that is within the constraint of k. So how we will calculate the dp at that index is we will look at the sorted list and subtract the window accordingly. So if we want to calculate this, what we will do is we will look here and subtract the window size, so it will be 2. So 9 minus 6. 9 minus 3 will be 6, so right here 6. And because prefix is the sum of all the previous subarrays and the current sub and the new subarrays given the new index, we will just add here and here. So 6 plus 9 is 15, 4 plus 5 is equal to 9, and so on and so forth. And the time complexity of nlogn, because of the sorted list, can take nlogn time. So now let's get to the more optimal way to solve this problem. Now the optimal solution is very similar. The same concept regarding dp and prefix is exactly the same. The only difference is instead of using a sorted list, which will take nlogn time each time we iterate and we have to take care of the window, we can just use a max queue and a minimum queue. As we iterate through window, if we see a smaller element, we can pop it. If we see a larger element than the current element, then we can pop it in min queue. And same as the last method, dp represents all the subarrays at that new index, and prefix represents all the subarrays at the previous indexes plus that current index, and we get that from adding the previous prefix index and the current dp index. And dp is also calculated through the max and min queue window. And by the way, for max queue and min queue, I will be using the index rather than the element itself. So let's go through this example real quick. I think for this problem, the example with visualization will make a lot more sense than explaining it. So let's go through it real quick. So first we come to the first element, it's 9. It's the current max element and the current min element. And dp, obviously there's one way to do it. There's 2 ways in the prefix because we can have an empty array and we can have 9. Now we get to 4. For 4, 9 minus 4 is greater than k, so we pop 9 from the max queue and minimum queue. And there is still one way, because since 9 minus 4 is greater, there's still only one way, but now there's 3 ways because we can have a 9 as a subarray, 4 as a subarray, and an empty subarray. So now we move on to 1. Since 4 minus 1 is less than k, for the max queue, we will keep 4 because it's the max element, and we will also have 1. And for the min queue, since 4 is greater, we pop 4 and then we add 2 to the min queue. And as you can see, there's 2 ways because right pointer would be 2 And the left pointer would be the left pointer minus 1, so it would be 3 minus 0, and that's 2, so that's why we put 2 here. And we get 5 from adding 2 and 3. And as you can see, there are 2 ways. And as we move to the next element, we will see that 1 is less than 3, so this will be popped. And for the min q, we will add this to the min q. So yeah, as you can see here, we have added the max q and min q, and then we get the dp by subtracting the right pointer, which is index 3 with value 5, and left pointer minus 1, which is 1. 5 minus 1 is 4, so that's how we get 4, and we get the prefix here by adding 5 and 4. And as you can see, there are currently 4 ways to partition them. And finally, 7 is larger than both 4 and 3, so they are both popped. And for the min q, we look from the back, we see that 7 minus 1 is greater than k, so that's why we pop index 2, which is 1, from the min q, as you can see here. And we get this element by subtracting index 4 by index 3 minus 1, which is index 2, so 9 minus 3 is 6. And we get this value by adding all the previous subarrays with the current newest one with the addition of 7. So 6 plus 9 equals 15. And as you can see, there are 6 ways to partition them. And we will always return the last element in dp as our result, which is 6. So the time complexity would be O of n, because it will only take n time to edit the max q and min q, and it will also only take n time to iterate through the elements in the array. And the space complexity will take O of n time, where n is the number of elements in the array, because the max q and min q and dp and prefix array will only take up to n space. So now let's get to the coding part. So first we will set mod to 10 to the 9th power plus 7, because it said that since the answer may be too large, we will have to modulo by that number. Now we will set the dp array, so 0 times length of nums plus 1, and the prefix will be the same. So I'll just copy and paste. And now we'll set min q to an empty q, and same for max q. And now we need to initialize dp of 0 and prefix of 0 to 1. And we'll start the left pointer at 0, and now we will iterate through the right pointer, so for right in range length of nums. And first we're going to check the max q. If anything from the ends of max q is less than the current number in nums, then we will pop it from the max q, so max q.pop. And then now we'll append the right pointer, and then the same logic applies with the min q, except now it will do if it is greater than nums of right. And then, well, that is the case, we will pop from the min q. And then finally we will append the right pointer. And now we will check if anything at the front of the queue, it breaks the difference of more than k. So while nums of max q0 and while nums q0, so the first element in the min queue, if that is greater than k, then we need to pop on the left. So if max q0, if min q0 is equal to a left pointer, then we need to pop on the left. And then we will add the left pointer increment by 1. Now if left pointer is greater than 0, then we will calculate the dp of right plus 1 by doing the prefix of the right pointer minus the prefix of left minus 1. Otherwise, if the left pointer is 0, then just do dp of right plus 1 is equal to prefix of right. And to calculate the prefix of right plus 1, we will do the previous prefix plus the dp at right plus 1. And finally, we can return dp of length of nums modulo by mod, see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.